everyone, and welcome back to this functions lesson. And here we will determine the equation for the exponential function. Now if you have to find the equation for the exponential function, we work with the equation y equals b to the power of x plus q. A is 1 or else the A must be given to you. Okay, so please make sure that you know that A is equal to 1 or else they will have to give you this A, and I'm going to put it in inverted commas. Otherwise they have to give you that A. Sometimes they write y equals a to the power of x plus q, but here the a means the same as the b. Okay, both are the basis for the power of x. So I told you the difference between those two before. There's actually no difference. They just swap the letters, so it doesn't matter. In this one, the b will determine if it's above or below the asymptote. Here the a determines if it's above or below the asymptote. This b to the power of x, that's the base of the power x. So that base actually tells me what's the shape of the exponential function. Here the a is the base of the power x, so that a tells me the shape of the exponential function. Okay, so I hope you got that. So I always just work with this one, so it doesn't really matter. So here, when the asymptote and another point on the function is given. Now, first of all, we are given an exponential function. We know that is an exponential function. So what do? We simply write here our equation. So we know that we are going to work with y equals, now this is b to the power of x plus q. Now why don't I put in the a? Because if a was any other value, they had to give it to you. Okay, and here they don't. So I know that the a is just a 1. So now what I do is I put in my q, just like we always do. So that means y equals b to the power of x plus 3. Okay, because q is my asymptote, right? And now, very easy, we simply substitute the new point, which is this one, which I will circle in green for you. That point, we take the x, we put it in x's place. We take the 7, we put it in y's place, and then we solve for b. So this will basically be 7 equals b to the power of 2 plus 3. And then we take this 3 to the other side, it becomes a minus 3. So 7 minus 3 is equal to 4 equals b to the power of 2. Then we rewrite this 4 into its prime basis, which will be equal to 2 to the power of 2 equals b to the power of 2. Now this is something you also know, that if the exponents are the same, it means that the basis will be equal. So basically the exponents are the same, so that means 2 equals b. And now let's rewrite this equation quickly, and it will become fx equals 2 to the power of x plus 3. And there it is. And we can quickly analyze this, because plus 3 is my asymptote. Look, it goes through plus 3, or they say it's y equals 3. And then what is my a? A is a 1, so it means that the function will be above the asymptote. Look, the purple line is above the asymptote. What is my b? B is greater than 1. That means from left to right, it moves away from my asymptote, and I am correct. Okay, so great. If you know what the shape should be and you understand the function and its equation, you can easily see if you worked correctly or not. Now let's go and try another example. Now here is another example where we want to determine the exponential function, and I already know a couple of things here. The asymptote is minus 3, so remember what I said. If we have to determine an exponential function, we always just work with y equals b to the power of x plus q. There is no a, okay? Otherwise they have to give you that a. So in this case we assume that it's only a 1. So this will be y equals, and then b to the power of x. What is my asymptote? It is a minus 3. So we include the minus 3 here. Then we go and take that other point, and we are going to do substitution. So the minus 2 goes into the place of the x, and the 6 goes into the place of the y. And then we have the following: 6 equals b to the power of minus 2 minus 3. Okay, move the constant terms. Minus 3 goes to that side, becomes a plus 3. 6 plus 3 is 9. Okay, so now I have 9 equals b to the power of negative 2. I have to rewrite this 9 into its prime basis so I can get at least an exponent that is the same as a 2. So this will be 3 to the power of 2 equals b to the power of minus 2. But now the exponents are not the same, so the bases are not the same. But I can rewrite 3 to the power of 2 as the following. I can say it's 1 over 3 to the power of negative 2 equals b to the power of negative 2. Now we also know that this, and this is a trick that you have to remember, that is a 1 over 3, and the 3 is to the power of negative 2. It means exactly the same as a third in brackets to the power of negative 2 equals b to the power of negative 2. And now I can say exponents are the same, so a third equals b. Okay, so don't forget this little trick. I can show you why this is the same, and I'll show you here on the side, because if I write this, it means exactly the same as a third in brackets to the power of negative 2, because 1 to the power of negative 2 over 3 to the power of negative 2, and then we know that 1 to the power of anything stays a 1, so it's 1 over 3 to the power of negative 2. And can you see why it's the same? So I just show you with the exponential definitions, which you have to know by now, right? We did it earlier on in the year. So now I know that b is a third, so let's write out this entire function again, and I'll do that in purple. So it will basically be, let's call it fx equals, and then we have a third in brackets to the power of x, and what is my asymptote? Minus 3. And it makes sense, right? Because that is my asymptote at minus 3. A third is a value greater than 0 but less than 1. So in other words, from left to right, it moves towards my asymptote. And we also know that a is a positive 1, so it will be above the asymptote. And there we go. So here's a little tricky part that you have to remember and practice. And then all our exponential definitions we can apply to help us solve for b. And please remember, when we determine the equation for an exponential function, we just work with the simplified version of the equation. We don't work with the a as well. We don't put it in because we assume a is a 1, or else they must give it to you. Okay, brilliant. So hope to see you again soon. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.